Crash Course Instrumentation, Episode 41. How to measure voltage safely and accurately. You've got your multimeter. You've got your probes. Now it's time to take a voltage measurement. But if you don't do it right, you might get a bad reading or a dangerous surprise. Today, we're diving into how to measure voltage safely, accurately, and with confidence. And yes, we'll cover current and resistance, amps and ohms, in upcoming episodes. For now, let's focus on mastering voltage. What is voltage, really? Voltage is the electrical potential difference between 2 points. Think of it like pressure in a water pipe. It's what pushes electrons through a circuit. A voltmeter, or the voltage mode on your digital multimeter, compares the potential between 2 test points and gives you a number. But to get a meaningful and safe reading, you need to follow a few key steps. Step 1. Set up your multimeter correctly. Plug the black lead into the COM jack and the red lead into the volts-ohms jack. Turn the selector dial to the voltage measurement setting. Most meters have separate positions for alternating current, AC, and direct current, DC. DC voltage is used in batteries, control panels, and most electronics. It has a steady polarity. AC voltage is used in power systems. It alternates polarity and can be dangerous at high levels. If you're not sure what kind of voltage you're measuring, check the documentation or ask a qualified tech. Modern meters with auto ranging will detect and adjust the range for you. If you're using a manual range meter, start with the highest setting and work downward until you get a solid reading. Step 2. Think through your circuit before probing. Voltage is always measured in parallel. This means you're placing your probes across 2 points. For example, from one terminal of a power supply to another, or across the legs of a component. Why parallel? Because you're comparing the potential difference between those 2 points. If you try to measure voltage in series, like you would for current, you won't get a usable result, and you might damage the meter. So remember, voltage all parallel, always. Know what voltage you expect. Are you checking for 24 volts DC, 120 volts AC? If your reading is much higher or lower than expected, something might be open, shorted, miswired, or de-energized. Step 3. Inspect your gear and test your setup. Before you take a measurement, check your probes. Make sure the insulation is intact. No cracks, no exposed wire. Confirm the probe tips are clean and firmly attached. Look at the meter's rating label. Are you using the right meter for the voltage and environment? Cat 2? Cat 3. Know your gear. Next, confirm that your meter and probes are working. Use the continuity test mode. Touch the 2 probe tips together. You should hear a beep or see a 0 reading. This verifies your leads are working and properly connected. Now you're ready to test for voltage. Step 4. Measure with confidence and control. Start with the black probe on the negative or ground terminal. Then place the red probe on the positive or test point. Keep your hands on the insulated portion of the probes. Avoid placing your fingers near the metal tips. Whenever possible, use test clips or probe holders to avoid slipping. One wrong move could short terminals or damage a live circuit. Once your probes are stable, read the value on the display. If you're unsure of your reading, lift the probes and repeat. Better to take your time than rush and make a costly error. Live dead live, a professional safety standard. Here's a key technique used by pros. 1. First, test a known live source. Confirm your meter reads voltage as expected. 2. Then test your target circuit. 3. Finally, retest the live source again to confirm your meter still works. This method, called live dead live, ensures your tools are functioning before and after every critical measurement. If your meter fails, you'll catch it. And if your test point reads 0, you'll know it's real. Step 5. Document and verify your work. Good technicians don't just take measurements, they track them. Create a checklist or worksheet with each test point, expected voltage, actual reading, and any notes or anomalies. Compare your readings with manufacturer documentation, wiring diagrams, or previous service records if available. Knowing what happened before can help you spot what's wrong now. Being methodical helps prevent missed steps, speeds up troubleshooting, and gives others confidence in your work. Did you know? Before modern multimeters, voltage was measured using electrostatic voltmeters, or delicate galvanometers, which detected small voltage changes using needle deflection. These early instruments were slow, fragile, and analog only, but they laid the foundation for today's rugged digital meters. Quick recap. Use the correct jacks. Black to COM, red to the volts-ohms jack. Select AC or DC voltage on your dial. Measure in parallel across 2 points. Inspect probes for safety and test with continuity mode. Use safe technique. Insulated grips and clips when possible. Confirm every reading with the live-dead-live method. Document each reading and reference technical resources or past notes. Thanks for watching episode 41 of Crash Course Instrumentation. Next up, we'll tackle how to measure current and why it's a little trickier than voltage. Thanks as always to Tony Kuphaldt and the ModEL open source community. You can find the full series at ibiblio.org/Kuphaldt.